Let's go ahead and look at these two series and calculate the interval of convergence. For the first one, we'll use the root test because we see that power of k on the outside. The root test will undo that. For the second one, we see a factorial, and we will use the ratio test for that. So with the root test, we're going to take the limit as k goes to infinity of the kth root of the absolute value of a sub k. Now, the only part of that a sub k that could possibly be negative is the x. The k's are positive. So what that means is that we can change this around a little bit. We can manipulate that absolute value symbol and move it so that it's only on the x, because that's the only part that could be negative. And so we'll have the kth root of all of that. The kth root will eliminate that kth power, and we'll be taking the limit of 8k absolute x as k goes to infinity. And this limit is going to be equal to infinity as long as x is not 0. And if x is 0, the limit will be 0. If x is 0, x equals 0 is the center of the series. So remember that a series always converges at its center. So when x is 0, we'll be adding 0 to itself forever, so that will be 0. We always have convergence at the center of the series. But if x is not 0, this limit will be infinity. And infinity is never less than 1. So for both the root and the ratio test, we will have convergence when this limit is less than 1. This is never less than 1. Except if x is 0. So therefore, our radius of convergence is 0. And the interval of convergence is nothing more than the center of the series. So this series is going to converge only for its center. Not super interesting. So that's one of the edge cases. Now, if we look at the second one, we are going to take the limit as k goes to infinity of the ratio of consecutive terms, and we are going to use absolute values. So that is the ratio of consecutive terms. So let's form 2x to the k plus 1. That's going to be absolute value, divided by k plus 1 factorial. We don't need to put the k plus 1 factorial in absolute value because it's always positive. And then we divide by the absolute value of a sub k, which means multiply by the reciprocal of the absolute value of a sub k. Again, k factorial, don't need absolute values. Down here, we will need it because x could be negative. And then we'll do some simplification. Let's see, we're left with, these 2's are going to cancel. And the k factorials, we are going to have one extra factor in the denominator. That one extra factor is going to be a k plus 1 in the denominator. And in terms of the x's, we've got one extra x in the numerator. And so we are going to be left with x in the numerator, but it has to be an absolute value. And this limit is as k goes to infinity. Now, we don't have to, but you can factor the absolute value of x out because this limit is based on k. The limit as k goes to infinity, and x has no k in it. So we have this. And that limit will be 0. So this denominator is going to infinity, and 1 divided by a denominator that's going to infinity will be 0. The fraction values are approaching 0. So what we see here is that this limit is 0, and this is less than 1 always. So this is always true, right? 0 is always less than 1, as opposed to up here, we had never less than 1 except for one case, and that was the center of the series. Down here, this is always less than 1, so that tells us then that the radius of convergence is infinite, because it's always true. And that tells us that our interval of convergence is the entire, oh, I said that backwards here. Our radius of convergence is infinity, and our interval of convergence goes from negative infinity all the way to positive infinity.